Well, congratulations to the Trapezoid, selected this year's award winner for the #1 quadrilateral. In honor, we're going to show you how you can find the area of this trapezoid, a couple different ways to model it, and a couple little tips or tricks to kind of help you out with it. Coming up next. Hi, this is Todd with The Land of Math. On this channel, we give you tips, advice, and strategies to help you help kids with math. So let's cut right to the show. When working with trapezoids, there's two key terms to know. The first is base, and there's base 1 and base 2. These are the two lines that are parallel with each other. The other key term to know is height. This is a line that goes straight up and down. You can also think of this as kind of the distance between the bases, base 1 and base 2. Now, here's a different trapezoid, and it's the same thing. You have the two lines that are parallel, base 1 and base 2, and then the line that connects them, the distance that connects them, is referred to as the height. If you're going to find the area of a trapezoid, you're more than likely going to see two basic formulas. The first one will be 1/2 times, in parentheses, base 1 plus base 2. And then we multiply it by the height. The other one you might see is when we add base 1 and base 2 together, just kind of like we did above, but this time we're going to divide by 2. Once we divide it by 2, just like above, we're going to multiply by the height. The thing you have to remember here is when we multiply by 1/2, and when we divide by 2, it's the exact same thing. Our answer will be the exact same. It doesn't matter. It's helpful to understand that in these two formulas, the 1/2 times base 1 plus base 2, or base 1 plus base 2 divided by 2, both of these are basically asking you to find the average of the two bases. You could think of it as the mean or the median, it doesn't matter. So you're just trying to find the average of those two. Next, we have 3 examples of finding area of a trapezoid. In the first example, we have a base of 6, we have another base of 12, and we have a height of 4. So when we set this up, we have 1/2 times, inside the parentheses is going to be the 6 plus the 12, we'll multiply by the height 4. We get 18 inside the parentheses, 1/2 times 18 is 9, and then 9 times 4 is going to be 36. Now, if we're using centimeters, we would just say that's 36 centimeters squared. If it was feet, it would be feet squared. In our next example, we have a base of 20 and 10, height of 8. So we're going to add the 10 plus the 20 inside the parenthesis. That'll give us 30. And we're going to multiply that by 8. Now, once we get to our 30 inside the parenthesis, half of 30 is 15. 15 times 8 is 120. In our last example coming up here, we have a base of 6 and another base of 12, and our height is 6. The height is actually more sideways than it is vertical. You can see we add our base and we get 18. We multiply it by 1/2, get 9. 9 times the height gives us 54 centimeters squared. And finally, we have 3 different ways that you can model this. In our first example, we have bases of 4 and 12, height of 4. We can rearrange this to create a rectangle that has a base of 8 now and a height of 4. On our second example, we have bases of 10 and 6. The height is 5. By again rearranging this, we can create a rectangle with a height of 5, base of 8. And on our final one here, we have bases of 6 and 12, height of 4. We can rearrange it to create a rectangle of a height of 4 and base of 9. So, hopefully you found this helpful. Please consider subscribing. Give us a thumbs up, that would be great. And we look forward to seeing you next time. What do you mean the trapezoid didn't win? The rhombus? Are you serious? The rhombus?